Thank you for the warm welcome. And at first, let me thank you, Jacob, for the technique, for helping me with the setup here. As you just heard, that's my name, and I'm a designer and a paper artist from Germany. And in my art, as an artist, I'm interested in the creation of abstract artworks that focus on pattern, rhythms, and movement. This artwork cannot move by itself, but if you change the angle of view, it creates the illusion of motion. Just like this artwork, it even can create the illusion of moving into two directions at the same time. But even this cannot move by itself. So the things that I love to do are objects that actually move and that transform from a flat state into a three-dimensional object. I brought some of my originals here so you can see the original scale. It's not the size of that projection, but it's just book-sized. My personal name for these types of sculptures is pop-up sculpture. So that's not an official term, that's my personal wording. And let me explain what I mean by that. And let me start by showing you some examples that I would not classify as pop-up sculptures. So when I explain what I'm doing as an artist, people often say, you're doing kirigami cards. Yes, I do these, but I wouldn't consider these to be pop-up sculptures. I think they lack the sculptural element. I am not a scientist, so if you see it differently, you're welcome. That's just my personal viewpoint. Then you have these structures that are similar to origami, like kirigami, made from one single sheet of paper, but if they're not attached to a backing sheet, so you don't have this transformation, I would also not classify them as pop-up sculptures. And then we have designs, all of these designs, sorry, that was too quick, just needs a second to start. Yeah. All the designs are by me, so I'm not blaming any other artists here. This is a transformation from the number 3 into the letter C and back. But if you remove all the color and illustrations, there's nothing left. So I would not consider pop-ups that need the illustrations to work as to be a pop-up sculpture. And finally, even if they open up to 180 degrees, if they just erect flat images, I think nice try, but it's not what I consider to be a full working pop-up sculpture. So as a quick summary, it should be, once again, it's not an official term, it should open to 180 degree or similar. Some of them are on tables that don't open to 180 degree, but 175, but I'm not that strict. They should be significant three-dimensional. I know you are all, there are many mathematicians. I know this is also three-dimensional, but you know what I'm talking about, hopefully. And it should not require additional color or illustrations. And my personal taste is that they should be a little bit larger than a pop-up greeting card. So my personal taste would be the size of a book. But don't take that too strict. It could also be a coffee book, table, what's the word? Coffee table book. So let's have a look at some pop-ups that meet these criteria. So this last design that you just saw, it's an actual design that I created a long time ago. I was studying graphic design, communication design in Dortmund. in Germany. And we had an interesting task. We should create three-dimensional objects from paper and board. And I would love to do that, but I lived so close to the university that I had an issue with the weather. It was raining and pouring. I said, walking with a big cardboard box through the city would be a problem. So I decided to create them as pop-ups. So transportation would be easy. That's the reason why I brought some of them here to this conference, because I could, because transportation is easy. But I didn't know how to do that. Because, hey, that's 34 years ago, 35 almost. And I had some books which would explain the techniques, but I just had to figure it out myself. And so I'm not a scientist, but just by trying it out, let's start by a double page of sturdy material. I had a paper strip with 3 folds and would place it onto the spine, and it would reach a certain position hovering over the ground. So like a triangle, reaching this position. And then I see, okay, which other position could I reach with the same length of paper? So I ended up with a whole sculptural thing that looks like this. When I open this now, I have it here, have a look at the moment when it opens, they all have the same length. And so, for a whole semester, for 6 months, I was working on a new project in this style week after week, and I failed a lot. It was not just, okay, 6 months, that's so many weeks, so you ended up with dozens of models. No, I didn't. In the end, I had about 10 models that I could present in my final, it was not the final exam, but for this course. And I was super happy with that, but then it hid it from the audience because I became a classical graphic designer and worked on this field for 20 years until friends of mine said, where are your pop-ups? Why are you not showing them online? And I was like, this is not a job. Who would be interested in this? Why should I do that? But I did, and I didn't have any projects from clients, so I filmed my students' work and put a 60-second video online, and this became super, the internet got mad about that, so it got, after 1 year it had 100,000 views, and after 2 years it had 1 million. Up to today it has almost 5 million views. And so I did this, it became my job. So let's have a look at some other projects. So this is another technical view on V-folds. So all the elements here are V-folds. The early model was with solid surfaces, but if I do newer models, I love to cut windows out so you can see the internal structure. And the first models were very basic, but that's not a downside. I love this very, very simple and clear structure. I don't need to go complex when I don't need to. I love complex models, so we'll see that in an instant. And as you can see, my hands, they're all about book size. When I'm creating more complex models, which I started to do several years after I finished my studies, I can no longer do just some early tests, but I have to cut out each element that I would need to see if it's working in the real world, because we have tension of paper, we have the direction of fibers in the paper itself. So probably, I always hope this is my last model, this will be it, but I don't know until all the tabs are glued together. And sometimes I finish here, and sometimes I have to redo it 2 or 3 or 4 times. There are projects where I have to redo it several times. Let us see 3 more. out the last object even to display. So if you want to have a closer look later, that's possible. So why am I building these things from paper? There are several reasons to do that. Because I started to work with paper, why change the material? No, it's actually paper can do one special, let's call it a trick, that I don't know that any other material could do. You can apply a groove. And then you can use this groove in paper engineering as a hinge. So not just like origami, you fold it and leave it in that state, but you can open it and move it to different positions, even fold it completely flat into one direction and the other as well. So imagine doing this when building a house. You build the walls and then you came with your magic wand and said, this is to be cut and this will be the hinge, and then you open the door. Paper can do this. And now let's talk about, when I'm talking about paper, actually there are several different materials that I would include into this topic, and it's sometimes a little bit blurry what I actually mean. So we have paper, we have cardboard, and we have some special substrates, and in reality they're not the same. So this is a simplified representation. Paper I would consider to be a thin material. Usually it's made from one sort of paper fibers. It's usually flexible, easy to fold, but usually you cannot do sturdy, you cannot use it for sturdy objects. Don't take me by the word, some of the objects are made from paper. However, as a generalization, I would prefer another material. So what about cardboard? Cardboard is absolutely not suitable. It's too thick, it's too heavy, it's too stiff, and it cannot be folded without special treatment. And here I don't mean a groove. If you have especially gray board, which you see on the image, you cannot just apply a groove. You have to do a partial cut, like a kiss cut or a score. And this will, of course, cut the paper into pieces. And when you then fold it, the fold is very easy to break and not durable. However, for the backing sheets of pop-ups, they're a wonderful material. This is covered in paper again. And once again, if you have thin cardboard, you can use it for pop-ups, so don't be that strict. And then we have a special material. It's not obvious to us, even if we use it every day. Think of chocolate boxes, cigarette boxes. Think of your favorite supplier of computer electronics. I just erased the fruit from the front. If you want to dig deeper into this topic, search for these two terms. But just for now, it's available in different weights. It's sturdy, but still flexible, but much sturdier than paper and much more flexible than cardboard. And it's engineered for perfect folds. So I think none of you has ever experienced that the lid of the cigarette box would fall off even after taking out the last cigarette. This is because this is usually made from several layers of paper with different fiber length. So speaking of the paper fibers, on the paper machine, during the production process, the fibers have a direction, and you have to be aware, not with every pop-up, but sometimes it plays a role if the paper fibers, in which direction they are arranged, especially if you put a weight on it. One version will be more sturdy, and the other will be more flexible. But as an artist, you can use this for your advantage. So let's look at swinging elements in a pop-up. And even if it looks random from this perspective, now have a look at this moment. There you can see a pattern in it. And once again, paper can do one thing that I don't know to do with any other material. All the pop-ups that you have seen so far have straight lines as folds. But you can even do a curved folding line. So the spine of this object is obviously a spiral, but it creates a volume in these two parts that the pop-up is made of. And it goes back and forth. So it's flat and then it's more dimensional and it's flat again. I don't know any other material that could do this. So for me, I would stick to paper. But as I told you, I'm not just an artist, I'm also a designer. And so my clients will ask me, hey, Peter, you can do so cool things. Can you do a stage design that is more than 10 meters wide and more than 5 meters high? And to earn my money, I usually say yes. But the working process is different. So when I'm working on these abstract works, I would start simple and then add complexity. But with clients' projects, not every time. I will show you different versions, but very often they start, this is our model, or this is our house, or this is our desire, what you have to build, and I have to kind of divide it, so it's reverse engineering. I know what the final outcome would be, and I have to find a way to make that work. So now speaking of really large objects, and I was so happy that yesterday Elizabeth would show a mini project, because I also have a mini project. It was supposed, the client sent me these images from a small model. It was to be built as a booth at a trade show, and their aim was to open a wall from top down, and between the two layers of the wall, there should be revealed a pop-up. And when we talked on the phone, I said, but that's not a pop-up, it's not 3D. I said, yeah, we cannot design it, we can build it, we are a booth construction company, we're professionals, but we don't have the capability to actually create the 3D design that can be folded. So I accepted the project, and after a long back and forth, this was the final design that I had to use as the basis. So as you can see, it's all flat, and here you see my scale model in measurements 1 to 10. This is already more than 1 meter wide, because the wall was to be 10.5 meters wide, 5.19 meters high, so I noted this in feet, 34.45 feet to 17 feet. So my model is made from paper, not the backing sheet, that's a stiffer board or foam board, but all my elements are paper. And to add volume to the flat images, of course, I had no view from the side because we only had the illustration as a basis. I added additional layers for the snouts, or made a little movement for this leg here. It moves to the side. So that's the final image. But I have a small model that can show it again. So even this model was, there is a movement in the foot. And so I sent this out to the booth construction company, but they didn't, of course, they didn't build it from paper. They did it from aluminum debond. This is just an illustration, but we have a foam core which makes it sturdy, and then like a sandwich, the bread sheets would be aluminum. And the booth constructors were so happy when they finished the first segment that they sent me this greasy cell phone video to get an image on how big it actually was and how heavy it was. And you will see in some seconds when it's opened more, you can even have a feeling of the weight. You can see, and of course they cannot just apply a groove. They have to cut it into pieces and then tape it to create a hinge, or actually apply a hinge to make that work. And of course I was like, where's the snout of the tiger? I said, yeah, we didn't build it because it's the levers are so strong and they create so much tension and pressure. We just, for safety reasons, we just got rid of it. So in the end, I have this model here if you want to have a closer look. And for the online community, you can see it now on your screen. This was what I asked them to do. And now let's have a look what they actually built that was possible. So here, that's an original extra, and it's the sound, so be aware it's a little. So just for the credits, this screen. And now the weight, just the walls without the pop-up weighed 2 tons, and the pop-up elements weighed 250 kilograms. And now look at the effect. I think it's a lot of effort for very little effect, just might. But still, I did it again, so because I was asked by an event company if we could do a huge pop-up book. So same setup, I was given images, how it should look like. So I couldn't change them. And then I would figure out in trial and error how to make them appear as 3D. And now, talking to the booth constructors, I said, don't make it that heavy, don't make it that deep, make it closer to the wall. So this, let me rush through the pages. Here is the presentation, and this time it was built from foam board, which is much lighter than aluminum debond, but has, again, not the property of just applying a groove. You have to cut it into pieces and then tape it on again. And you will see, if you focus on that in the video now, you see how wiggly it was. Actually, it survived the rehearsal and the presentation, and then they threw it away. Because it survived the presentation, but it... So the turning means the ice is not a sitting effect, it's actually... So when building pop-ups is such a problem in that scale, I was super happy when a client asked me if I could do a pop-up which should be big, but in a big book size, like 1 meter in depth and 1.4 meters in width. And they allowed me to use my personal approach. So I could start with an easy folding technique that I would present to my client. And they said, okay, we like the movement to the side, but there's not enough going on in the center. So can you add something more? So I would add something more in the center. And then it turned out to look like a flower. I wasn't intending to create a flower, but then they said, hey, if it already looks like a flower, let's do that. Okay, I'm fine with this. Before I would do the final outlines, of course, based on my early models, I would create a perfect model with all the measurements. And based on this, I would build my actual design. I also brought this to this place. So it should do, actually there were 2 pop-ups, and one should be open to this flower object, and the other would be open to this crystal-like structure. You can see that on screen. And my models are in scale 1 to 5, so 5 times smaller. It would just be 5 times bigger in reality. These models are from paper, so very, very soft. So I was sure my client would be able to build them with their material. And one more, even if they work in white, my client wanted them to have in color, so I also created a colored version. And I'm okay with that. Now, speaking of materials, the company for whom I made that, they create cutting machines, laser cutting machines that work with different substrates. So on the trade show, they wanted to show all the substrate that they could handle. So we had to make parts of the final designs with corrugated board. And that's a problem. Corrugated super stiff unless you accidentally or intentionally create such a groove, because then it will fall into pieces and will be as weak as it could be. But I thought I was on the safe side because the crystal object would work perfectly. So you see me assembling it. But with the flower shape, the client sent me this cell phone video, so excuse the bad quality. Please have a look at the red arrow that appears in a second. The front part in corrugated would be already so heavy that it would go further down that I needed it to do, and I was afraid that it wouldn't go up but fold in the wrong direction. So let me show that again. Without the red arrow, now you know where to look at. So I redesigned that and made this section much steeper. So this angle now is very more clearly visible. And so we built it, and so we brought it to the trade show in Düsseldorf, and it was working for 11 days straight. We switched the table on in the morning at 9, and it was going all day through until 6 o'clock. And did my improvement save us from the model being damaged? No, because when it was switched off, it's a trade show for paper enthusiasts, Druck and print and paper. So people would touch it in the evening, say, what material is it made of? And they accidentally created additional creases, so I had to apply a metal support secretly attached to the backside, so it survived as well. So if making it large, scaling it down, what about making small pop-ups, putting more on a double page? I would love to give you an example of one of the most complex designs that I ever did. And the client asked me to, I have the aim to do one object on a double page, and now they asked me to create an entire film scene, a set of an amusement park on a double page. We agreed. It's for a stop-motion film that would be published on Netflix. The stop-motion puppets have the size of about 12 inches, 30 centimeters, and we were agreeing that I wouldn't build the whole pop-up scene in original scale, so I was allowed to do it in book size. And it was clear from the beginning, this is a drawing from my client, they didn't want to have just one fold, they wanted to have one main fold and then 2 more flaps on the sides. And good for me, I was confused when they sent me the storyboard. I said, which is the design that you want? They say, it's up to you. You can do whatever you want, do any carousel you like, as long as it looks good on film, but please add a roller coaster. So this is not my first model that I'm showing you here. It's already the 3rd round, but I will start to create volumes that you can fold. And please focus on everything, but of course on the wall in the back, because this is supposed to become translated into a roller coaster. So I'm starting with a much bigger form than I will need. So I can cut away everything that doesn't look like a roller coaster. So that's my working process. And the other objects are just placeholders. Even the technique could be replaced with other paper engineering techniques, but I just had to find out how deep the back wall would go into the model when it's folded flat and how high it would erect when the pop-up is opened. So in several models, so this is a photograph of this wall object, I transformed this solid wall into new models, and with each step I cut away something or added something, so it looked more and more like the roller coaster that I wanted to build. But even if it looks so promising on the image, the model it created so much tension and pressure on the folds that I couldn't do it this way. There's another model that's already broken, so my journey didn't end here, but I still had to improve it. And the solution came with another sort of connectors. I did no longer glue everything. There are some glues still, gluing points, but I connected them with tabs and slots, but they are really tiny. But that led to the fact that I could easily open and close it, and even the assembly was more accurate, and it would even fold flatter when it's folded down. So here's another close-up for the online community, and here you see just the part with the roller coaster, how I presented this to the client. So they were super happy, and while they were watching this video, I was already working on the next model, which was supposed to be a swing ride carousel, charoplane, this thing where you sit in a seat and it turns around. And stop it here. Wave swinger merry-go-round, that's on Wikipedia. And once again, I have a guess how it should be working, but to make it actually work, I usually need several attempts. And with each attempt, I think, oh, now that's the one. And sometimes it's not, so I have to do another model and another. But when I finished it and presented it to the client, I already told them, this is not the final size because it's just too big. If you place it in front of the roller coaster, it just looks too big. There's something broken here. So I informed them that I would scale this down to 90% when applying it to the entire scene. And they sent me an email and said, no, not just 90%. We created an additional scene in the movie. Now we will show the puppets, 30-centimeter puppets, building the pop-up. We made an additional scene. So now we need your models in 30% or maybe 25% of the size. Okay, so this was finished that moment. So I just sent them the actual plans. It's not just scaling down because of the slots. You have to do some trickery, but basically it was working. So the film team, Emily Nielsen and Nicholas Blake from the Netflix film company, they sent me these images like, look at this, we made it work. It looks a bit ugly. This was the first attempt. In the video, it looks much more professional, but hey, we were sure it would be working. But what about the Ferris wheel? Having found out that the technique that I used for the roller coaster was working so good, I created the Ferris wheel in the similar fashion, but for the small gondolas, the struts were so tiny that there was no chance to scale them down. So this is my large model to be applied to the entire film scene, the whole movie park, not movie park, amusement park. They called it the Dream Fair. But then I had to create, not as a bonus, it was a job, but hey, a small scale model, which just looks similar. When you watch the video, you cannot see the difference because it's all moving and people are reacting to it, but it's actually a second version, which just looks similar, but technically much easier. Now back to the main model. Only these two models were to be scaled down. For the large model, I invented and created more and more small-sized models that would be placed on the entire scene because I was sure they would not be scaled down even more. I'm showing the horse carousel because this is not seen in the Netflix video, so now you know it's there because you cannot see it in the final scene. And with each week, I would add more complexity and eventually, I came up with the final scene. So this is my presentation video on how I presented my model to the film team. Now, but because of copyright issues, of course, we cannot do a live stream of Netflix. So you can find it on Netflix. And if you don't want to watch the entire movie, please have a look at the minute 19. There we see the two Dahmen brothers, the two puppets, working with the small scale models, building them. And if you watch, scroll forward to 1 hour 36, you will see the scene that you just saw, but with enhancement. Because they are stop motion artists, they used my model and they built a copy, and with their copy, it can no longer do the pop-up effect, but in their version, all the carousels are moving. But please note, this is not my model. They made it based on my plans, but they made models that can actually rotate and do other things. And for the people here in the room, you can have a look at this because I brought this model to this place. My final model, of course, I made a super perfect model that I sent out to Portland, Oregon. And on the side note, it was even nominated for a Hollywood award. And I was super happy to be, they flew me into Hollywood, but I didn't win. The award went to The Way of Water by James Cameron. So it's okay, I think it's okay to lose against James Cameron. So back to my, I think 3 minutes to my favorite art form. So if it comes to my personal taste, I would prefer to do pop-ups in the best possible fashion, and that's staying with paper, staying with perfect paper in the perfect size, with perfect cuts and all the details that I love to do. And I was lucky enough to have a project that would cover all this. I was invited to do the stage designs for children's opera, but I was allowed to do them in book size. So for the children's opera Salt Ice, you see the actor and she comes onto the stage and places the original book-sized object onto a rotating table, so the audience will see how big it actually is. And at the same time, they will project large images of the same pop-up on the back of the screen. You can find the whole recording online. You don't have to search for it. When you find my name and you go to my website, you will find all the links to YouTube videos. Everything that I've showed you here, you'll find all of this online. But I would like to show you the 5 pop-up sculptures and how I presented them to the client. So these are not the recordings that you see on stage, but these are my films that I made for presentation purposes. The play was, the premiere was 6 weeks ago in Austria. It was part of the European Capital of Culture. And now I thank you for your attention. You can find all of the images online.
Absolutely lovely.
Thank you.
If I may, as a chair, below a little comment, I like your abstract things that you invent yourself the most.
Thank you. Same here, but because it's about scale, I hope you don't mind that I brought the big ones as well.
Okay, are there any questions? Marek?
How do you estimate durability of your sculpture? So how
Good
many
question.
times you can fold and unfold them?
That's a really good question because people think, oh, that's just paper, it will break. The sphere thing that I showed you at the beginning, I made that 34 years ago, and it broke at the very first opening because I made a mistake. And then I found another way to make the opening movement, and since then it's operating without any problems. So for 34 years, no issues anymore. So if you do it correctly, and if you use a paper that's not age resistant, so because of acids, things like that, but if you use a proper material, I think you can open and close it to infinity.
So this is more a matter of construction rather than of the durability of
No, you're right. It's both. I talk about paper board. I visited even a paper mill in Sweden. They produce paper that is in the production process made from several layers, but on the fly. It's not glued together, and they have larger fibers from fir trees on the outer sheets and shorter fibers from birch trees on the inside. And if you apply a groove, then the outer fibers will just bend, but the inner fibers will loosen enough. So from that moment on, there is no more movement that goes on top of this. So then you have a more or less stable situation.
Charles?
So I'm a materials physicist, so I have materials questions. I'm guessing that the paper you prefer to use is about 1/10 of a millimeter thick. And you say you get this from a...
No, different. I use different types. Even I don't know how the actual dimensions, but the favorite paper has about, I think, it's 3/4 of a millimeter thick.
Okay.
Or maybe 1/2 millimeter. That's 220 grams of this special paper. But my artworks are made from paper, and actually it's not well performing. So I sometimes have to double it up to make it sturdy enough. But for my artworks, I prefer this super white paper. But the perfect paper, unfortunately, has a slightly yellowish. It's not yellow. It's not that bright. So I always have to work with a paper that is good for the project.
But what does the company mainly make the paper for? You're not keeping them in business alone. So what is the main use
the main brand name for this paper is Unveiling, made by a Swedish paper mill called Iggesund, now the Holman Group. I know there are several other substrates, but they call it like the state of the art. So Unveiling would be the brand of your choice.
If they go out of business, how many other choices do you have?
A few. There are, I think, 3 more in the world, and especially when you have projects in different countries, you always have to see if this paper is available. And to add some more, when I'm working for companies where I have no access to the production side, like when I'm working for Museum of Modern Art, they will produce the cards somewhere in China, and I don't even know the plant. I have to do a design that would work with almost any paper.
Okay.
David?
Thank you.
As long as we're in a mathematical institute, as you may know, I'm not sure how much math you know, but in differential topology, a piece of paper can just have Gaussian curvature of 0, meaning you cannot make it into a sphere, which has a Gaussian curvature of 1/r, but you can make a cone because along one direction. So I'm sure you're familiar with Richard Serra's work, these enormous tilted arcs and so forth. All of those have Gaussian curvature 0. They were made from sheets that then get bent in certain ways and give final cuts. So I was noticing on yours that almost all your paper pieces where you see a beautiful curve, and there are plenty of them, either you cut a curve around the outside boundary, or you have lots of flat things like triangles, and it's where you place them that have a curve. But Sarah does something fundamentally different, and so that all those things that look like they're very curved and so have Gaussian curvature 0. So you may be interested in getting those kinds of curves by the way he basically does it is cut the outside edges instead of being like flat. They'll have a curve here, and then when you make that be flat on the ground, the whole thing will curve to have a tilted arc. And if you've been to Guggenheim Bilbao, you've seen them all.
I think for me, I just have to try that out. I just have to make it work. So I'm receiving a lot of suggestions by email, or people who say, can you do this or that? Thank you for this input. I will think about that. But I don't just have a simple answer to that. So I'm requested very often by architects who say, can you build this as a pop-up, and say, you made it, that it holds storm and earthquake and the forces of nature, and now you want me to build it as a collapsible building. How should I do that?
Before I allow Alan to speak, I just want to say that that Sarah just died 3 days ago.
Of course, yeah, last week.
3 days
Oh my
ago.
gosh.
Yeah. He just died. Alan?
Do you have any models of a vacuum cleaner?
In the vacuum
Do
cleaner?
you have any models of a vacuum cleaner?
No, but I have a model of a hairdryer, but I'm not allowed to show it when we're live streaming, but I can show it to you when we're offline.
Okay.
I made an entire campaign for a huge British but international brand, and it was super successful, but I'm not allowed to show it when we're streaming.
Okay, thank you.
Andy?
You're designing basically for two static moments. The one that we see is when it's open and the paper is all in the place that makes the form. how do you ever have to sort of redesign your model so that it can close and the pieces don't knock into each other or not lay flat? And as you balance those two things, how do you have to change your designs in order to get both of them to be achievable?
It just depends. So I sometimes when I'm just adding things, I start with a motion that I already know it would be working. Then I can exaggerate it and see how far I can go. But with the client jobs, usually I have to build a certain building. Then I have to try it out, and sometimes, or very often, several different techniques are stacked on each other. So when I can do the basic movement, I will send my clients the information, we can do it, but I just don't know the level of detail, and during the next days I will find out how far we can go. So I think a number between 8 and 12 would be a usual way of, so I think usually if it's complex, it's rather 11, then just 5, but it depends on just on the project. But I have to build it several times. And if it's complex, I have to rebuild everything because I need my raw model to compare it to the next. I cannot just destroy it. If it's just a part, I will do that, replace the part. But if it's entirely somehow off, I have to build an entirely new model and compare them.
David?
So you talked about what's not pop-up art at the beginning.
No, it's still a pop-up.
Yeah.
I would just not call it a pop-up sculpture.
Sculpture, okay. But so what do you allow yourself? I noticed none of your pieces had any elements which had zero bending stiffness, so strings or cloth materials which you could use in tension but not in compression.
I know that several other artists using these things and other things as well, like foil, fabric, strings. Even I have a colleague from the US, G. Key, she's from Asia originally. She even created and did a patent on this, where you can add electric conducts on the page and you have LED lights, so it can even have light on it. From my personal taste, I just love to do the plain paper things. So that's even the reason why I prefer to do it just in white. But if a project would need to have the strings on it, I would just do that. But for my art, I would just love to stay with paper. But it's just a matter of taste.
So things like what you're talking about, for example, tensegrity structures, you know, with some stiff elements, is very different.
You can find them. I think David Carter from America did some of these constructions. David A. Carter. And there are crazy specialists like Matthew Reinhardt who does all the Star Wars and Disney and Harry Potter pop-up books, and you will find inventions with rotating things and super detailed stuff, which I don't even know how to do it unless I buy the book and say, oh, that's how I did it. But you have to invent these forms. It's like just like in the music. I have my field and I've still not explored what I can do in my field. So at the moment, I'm not reaching out to other more materials.
And Sarah?
To bounce on the question from Andrew, I think I like the sobriety and the complexity of your work, but I was surprised by the beauty as well of when it is folding. I think it's not only when it is shut or folded and open. I think it's very interesting when the transformation of the shape.
I totally agree.
Wonder if you were trying sometimes different way of folding, so it could be very interesting to look at it till the end.
Absolutely, absolutely. I brought it to this place, but I cannot hold it with my hand. It has to sit on a table. When you try to forget that my Dream Fair park shows carousels, and if you just look at this as objects, and then when I open it and close it, you will see there are different motions at the same time. So the front part moves forward. There are two like tower structures that go up. There is a mountain thing that folds in like two motions at the same time. So there is a lot going on, but of course we are distracted by seeing, oh, that's a carousel. Yes, and when I film my models, I always do it very slow because people can enjoy the moment of motion. I know other colleagues who do it like, so it's just, now it's 3D, now it's gone. I love to celebrate the moment, the transformation, absolutely.
It's a kind of
Absolutely. But it depends on the model. So sometimes it's just more interesting. So here I think the closing is more interesting because these points, they seem to touch itself, but then it goes, yeah, like a melody. And of course, once again, it's about rhythm and pattern, and even I think it has even a musical aspect to it.
What about the sound of
Oh yeah. Can you hear that? Next time I will record it and we show it on the large speakers.
So I think the sculptures are very elegant.
Thank you.
I just love them. And I guess my question is, if I understand correctly, you're doing this all as like a craft medium, as analog. You're not using a computer to figure out the folds. Had you considered going to computer, or do you just love the tactile quality of the craft?
It's a back and forth, and it's an iterative process. So I know that I give me the image of just working by hand, but actually the moment I know how it's working, if I know the angles and the dimensions, I will just create it in the computer. If I don't know them, I will detach all the elements, scan them on the flatbed scanner, create vector designs, and then in the first place I would print them out and put them together and see if they're working. In the next level, I would no longer print them, but I have a cutting machine which can be set to a fraction of a millimeter, I think a quarter of a millimeter. So then I can cut out designs which I couldn't do by hand because they need to be so exact that I can decide, okay, this angle is not 5 degrees, but it's 5 degrees, and that's where you need a computer for. And I couldn't do this 30 years ago, but now I can, and I'm doing this. Of course, why should I draw a circle by hand if I have a compass? And that's the same with buildings. When the client says, can you do my complex building? Of course, I would start with the architectural plans, print them out, fold them by hand, see what I can do, and then draw my plans in the computer based on my experience, and then back and forth.
I feel a sense of relief knowing that you're
Yeah, no, I'm not a super brain or, no. I'm using machines.
I want to make a comment that about a few months ago there was a special issue of National Geographic called Folded, with the whole set of works connected with folding. And one of the points there was that there is a lot of folding and unfolding in nature. For example, insects, when they come out of their pupa stage, spread their wings and they have creases. So I'm just wondering if you've thought of being inspired by insects and other living things that unfold to live.
Of course, inspiration is everywhere, and of course I love to watch these videos. Now you can find them online on Instagram and so on. I always watch them back and forth. But in my approach, the insects, they have muscles, so they can unfold their wings using, I think it's muscles, maybe it's pressure of pressure.
It's not so simple. Yeah.
Or hydro things. But in a pop-up, I would have invented something that makes it open. But you can find like Harry Potter, you have dragons, and there are online available books where you can see birds spread their wings and dragons spread their wings, and probably insects as well. So yes, it's all inspiration. I just need to do it. So that's a time issue.
All right, I propose we have coffee. Peter, can you put things also?
Yes and no. I will give you something that you can touch with your hands, but I'd love you to ask me. I will operate some of them for you, so you can film them, see them from outside. But and don't come near with coffee, please. I will do it on the first row here.
Yeah. All right. Thank you.
Thank you.